Okay, folks. So where are we at right now, then? We are at the point right now, today the graded assignment is due, the worksheet. 5-1, 5-2, 5-3, 5-4, those are all due and need to get into me. So 5-1 through 5-4 are all due, and that graded assignment is all due. So those are 5 assignments from this chapter so far that are due and need to be into me. The other day, then, we went through the notes to make sure that we covered all of the examples in your notes, so I at least know that we had gone over a problem of law of sines for ambiguous case and for angles. You have not yet had the opportunity to ask questions out of 5.5, so that's where we will start today. We'll take a couple questions out of 5.5, and then we'll get into law of cosines. Austin, 42. Now tomorrow we're just going to use tomorrow as a work day. I'm assuming all the seniors are out tomorrow. You got a golf match. All the other seniors, are you going to be out though? Okay, so tomorrow's probably just going to be a work day because we're losing the seniors again. But 42. Ferris wheel has 16 evenly spaced cars. The distance between adjacent cars is 15.5 feet. Find the radius of the wheel to the nearest tenth of a foot. Okay, so what's going on here? We have a Ferris wheel. Really don't need to see all the Ferris wheels. I just need to see 2 adjacent carts. So here's one cart. Here would be another cart. And I know that the distance between adjacent chairs, I know this distance right here to be what? Okay, now does everybody see the Ferris wheel here? Do I need to draw the whole Ferris wheel in 16 carts? No. Okay, but basically what's going on here is a Ferris wheel represents a complete circle, right? Well, we're taking 16 points on that circle, and they're evenly spaced out. So I need to find, bless you, this angle that's in between the adjacent carts. And how would I do that? We've got a Ferris wheel. We've got a circle. We've got a pie. That pie has been divided into 16 slices. How would I find the angle of one of those? 360 divided by 16, or 2 pi. Divided by 16. Either way, it would not matter. So if we take that full pie and divide it up into 16 slices, then we have an angle of 22.5 degrees down here. Does this take care of the rest of the problem now for you? Okay, so that was what hung you up, was not knowing an angle then, right? Okay, so we know 22.5 degrees down here. Folks, is this distance the same as that distance right there? It's got to be, right? Have you ever seen a Ferris wheel where one cart's out longer than the other? That would be kind of an awkward Ferris wheel, wouldn't it? Both of those 2 lengths represent the what of the Ferris wheel? The radius of the Ferris wheel. They've got to be the same. Well, if these 2 sides are the same, then these 2 angles have got to be the same as well, right? They've got to be the same. They both have to be 180 minus 22.5 divided by 2. Tell me what they're both equal to. 78.75, 78.75, 22.5. Opposite of that is 15.5. I need to know the radius. Problem solved? Yes. Do we have the side angle pair we need? Yes. And then does it matter which of the R's we find? Absolutely not. So, Austin, you're just going to tell me the setup here for the law of sines, and then I'm going to leave it to you. 15.5 over the sine of 22.5. Equals R over the sine of 78.75. Good. Okay. So again, it's all just based here on, you've got a full circle. You're going to divide that circle into 16 pieces. So each pi represents a 1/16 of your whole circle. So that angle has got to be a 1/16 of 360. So that angle is 22.5. The other two have to be equal because we got an isosceles triangle. Now I've got my law of sines set up. All right, with 42. Okay, well, 54. We are going to use the law of sines and the cofunction identities to derive the following formulas from right triangle trig. Okay, so we're all comfortable with sine being O over H, cosine A over H, and tangent. I tell you though, it's a good problem. We didn't have it for homework. I'm not going to waste class time on it, but it's really a good exercise and gives you a good understanding of trig. So if you want to look at it and bring it in with me outside of class, I'd love to look at it with you. Okay, well, all right, Cheyenne, 36. We're just solving the triangle, is that right? Yeah, respond in one of the following ways. It can't be solved with the law of sines. No triangle can be formed. Or if a triangle can be formed, we need to solve the triangle. So it's possible that we might have how many triangles? It's possible we might need to solve 2 triangles. Maybe only one or none. So 36. What's the very first thing I should do with 36? I'm a very visual learner. I need to see this triangle. And this is triangle what? How do you know it's ABC? Your 2 sides are A and B, and the angle they gave you is C. So this has got to be a triangle ABC. Does it matter how I label it? Absolutely not. Side A being 19, side B being 22, angle C being 65 degrees. My answer to this problem is can't be solved with law of sines, can it? Okay? What do we need for law of sines, folks? I need a side angle pair. Well, the issue is they've only given me what? One angle. They've only given me one angle. Is there any way for me to determine the measure of any of the other angles then if all I know is one? No, unless one of the sides they gave me was opposite. Yeah, if it was corresponding to that angle. And the 2 sides they've given me don't correspond to that angle. I could use law of what? Yeah, I could use law of cosines to find what? What part of that triangle up there would I be able to find knowing side A and B and the included angle C? Side C. Once I knew side C, then could I use law of sines to find any of the other 2 angles? Yes. But the answer to this one, it can't be solved with law of sines. This is a law of cosines one. All right, with 36? Okay, I'll take time for one more before I get into the notes. Is there another one we'd like to see before we get into notes? Austin, go ahead. 21. Does that fall under the same category? No. 2 triangles can be formed. We need to solve both of them. Okay. Okay, do I have a corresponding side angle pair? We do. Okay, so what are we going to say here? 18 over the sine of 68 degrees. 19 over the sine of angle A. Okay, so we're going to say that angle A is equal to inverse sine of 19 sine 68 degrees over 18. And we're going to say then that angle A could be this or that, right? Okay, and so then this is going to lead us into, and I think they said both are going to work, so this is going to lead us into 2 triangles then that we need to solve. Okay, so ultimately down here, end game, we're going to have and angle A, angle B, angle C, side A, side B, side C for one triangle. And then we're going to have an angle A, angle B, angle C, side A, side B, side C for a second set, right? Okay. Now, we do know that A and C are 18 and 19. Did I define those right? Is A 19 and C 18? Is that right? Okay. And then angle C, they said, was 68. So those will be consistent between the two triangles, but those other three parts will fluctuate now. Okay? So let's go ahead and do this. Folks, again, the first thing I've always trained you to do with this problem. What's the first thing we should do? Louder. Check what mode we're in. Ultimately, does that matter, though? Do you remember what I showed you this year where it doesn't matter? We can put the degree symbol in there. So I don't care what mode I'm in. I'm going to put the degree symbol in. Okay? So clear out, second sign. And then I want 19 sine 68 degrees. And I'm going to divide that by 18. Why don't I need parentheses inside here? Is it going to do the multiplication before it does the division? Yes, the order of operations, so it is. So I get that, and then 180 minus that. Any indications on rounding on this one? Did it say? Okay, rule of thumb, two places then. So 78.15. What's the other one? 101.85. Yeah, that's fine. Okay, so that's angle A, right? So angle A could be 78.15, or over here it could be obtuse at 101.85. All right, so find your other two angles for me. What's B going to be for the, over here, what's angle B going to be? So 180 minus 68 minus 78.15, what's angle B over here? 33.85? 33.85, what's angle B going to be over here? $10.15. Okay, and now just stick with law of sines to find side B. Okay, so side B is going to equal, and let me just go ahead and do this up here, B over sine B to kind of help you out. So what is B going to be equal to? 18 sine B divided by sine of 68. Okay, so first we'll go with 18 sine 33.85 divided by the sine of 68. $10.81. Okay, and now change it to 10.15. Change your 33.85 to 10.15. 3.42. Okay, take a look at these. We've got to check for reasonableness. Is the largest, and let's look over here first. Largest side opposite largest angle? Smallest side opposite smallest angle? Yes. Do any two sides add to be greater than the third? Yes. Triangle inequality holds, so on and so forth. That one's good. How about over here? Largest side opposite largest angle? Smallest side opposite smallest angle? Does the sum of any two sides add up to more than the third? Yes. Both of these are going to work for us. We're solving both of them down through. Okay. All right, with 21? Okay. Again, if you've got some more questions, feel free to ask them. Come and see me outside of class. We'll get those questions taken care of. But law of cosines. You tell me then, what is the law of cosines state? Okay, so the whole formula says that. What's on the other side of the equal sign, though? What equals a squared plus b squared? The third side. C squared is equal to a squared plus b squared minus 2ab cosine of c. Okay, so the law of cosines, we don't need a corresponding side angle pair. Okay, that's not going to give us anything for the law of cosines. Law of cosines needs what? And you can give me either two of the scenarios. What do I need for law of cosines? All three sides. If I know the C, the A, and the B, I can find angle C. So if I know all three sides, I can find the angle. What other case can I work with? Two sides, A and B, and what angle? The included angle. If I know two sides and the included angle, I can find the third side. So just like law of sines could be used to find angles and sides, law of cosines can be used to find angles and sides. And remember last year we kind of defined law of cosines as being the Pythagorean theorem for any triangle. Why did we call it the Pythagorean theorem for any triangle? The Pythagorean theorem is embedded in there, right? And what happens if that angle is a 90-degree angle? What is the cosine of a 90-degree angle? 0, which does what to that whole third term? Knocks it all out, and it leaves me with the what? The Pythagorean theorem. It leaves me with the Pythagorean theorem. So this is the Pythagorean theorem for all triangles. Now, remember what we did last year? How we solved this for angle C? Let's do that again. Let's solve this for cosine C. I do not like to treat these as two different formulas because they aren't. But some of us like to memorize formulas as opposed to being able to do the work to get it down to find them. Okay? So I am going to solve this equation right here for cosine C. Okay? So the first thing I've done is I've flopped sides. All right? I've moved this whole side over to here and set it equal to C squared. So if I'm going to solve this for cosine C, what is the first thing that's already on the other side that's not going to move? C squared. And what am I going to have to do to C squared? To first just get this right here, the negative 2ab cosine C by itself. What are we going to have to do first? Subtract off a squared and subtract off b squared. So C squared minus a squared minus b squared is going to give me negative 2ab cosine C. Well, how am I going to get the cosine C by itself then? We've got to divide by those three factors. We've got to divide by negative 2ab. So, law of cosines can be used to find a side. Law of cosines can be used to find an angle. Very importantly, folks, if I want to find angle C, then which side do I have to start with in the formula? Side C. The A and the B are the negatives, and they carry down to the bottom. If I wanted to find angle A, then what do I start with here? A squared, and the other two go here. Okay, very important. Whichever angle you're finding, you've got to start with that side on the other one. Okay? So we can use law of cosines to find a side. We can use law of cosines to find an angle. But what's nice about using law of cosines to find an angle? There's no ambiguity. Ambiguity. Okay? If cosine C ends up being positive, it's going to be a quadrant 1 angle. If it ends up being negative, it would be a quadrant 2 angle. It would be a quadrant 2 angle. It can't be quadrant 3. Why? Why could the angle not be a quadrant 3 angle? What are we talking about here? We're talking about a triangle, right? A triangle can only have angles between 0 and 180, right? Quadrant 3 would be taking me outside of that. Okay, so it's only the second quadrant angle if it's negative, the first quadrant angle if it's positive. So we can use law of cosines to find both of these. Okay, so that's where we're going to start with today, and I think probably just end with today is just the law of cosines. Do we need to do any of these, folks? Are we comfortable with doing this? Okay, so inverse cosine to find what the angle is. Now here we're going to just do inverse cosine of what, though? 0.25. We're going to find the what? The what angle? The reference angle. And then we're going to apply it to the quadrants where cosine is negative. Folks, and again, I really tried to harp on this last year. When you use second, sine, cosine, or tangent, you always put a positive value after it. Because you're only finding a what? A reference angle. And then you apply it to wherever the quadrants are where the function is either positive or negative. This would be inverse cosine 0.25. You'd get your angle, and then you'd apply it to quadrant 2 and 3 where cosine is negative. Solving equations here, no big deal on those ones. You know, this, again, we've got a law of cosine set up here. How would you solve it? So on and so forth. No big deal there. All right. We are going to get the law of cosines used today. Next week we'll talk about the area formulas. We've already used Hero's formula, right? Hero or Heron's formula. Now what was nice about Heron's formula, we only needed to know what to find the area. Just the 3 sides, right? And what did it involve finding? What did we first have to find? What did we find with Hero's formula? No. We did find the area ultimately, but what did we first need to find with it? If you'll remember, Hero's formula was the square root of s times s minus a times s minus b times s minus c. What was that s? So what do we call that when we add all 3 sides of the triangle together? The perimeter. And then when you divide it by 2, you're only finding half the perimeter. A semi-perimeter. Semi-perimeter. We had to find a semi-perimeter and then multiply that, take the difference of each of the sides with the semi-perimeter and take their products together. So we'll talk about Hero's formula and the basic area formula, not 1/2 base times height. When did we get rid of 1/2 base times height? Geometry in Algebra 1. Okay, there's a trig formula. What is the trig formula for area? 1/2 AB sine C, and then we're going to look at some applications. So let's get down here to all right. Side A is 10, side B is 4, angle C is 25. Do I have a side angle pair? No, I do not. Do I have all 3 sides? No, I do not. Do I have 2 sides in the angle between them? Yes. Okay, I've got side A and B, and C would be the angle that is between those 2. So I can use what? I can use law of cosines. We're going to use law of cosines to solve for what? What is the third side? C. So we would start with the formula. C squared equals A squared plus B squared minus 2AB cosine C. Is it still very important to write that formula down, folks? Yes. Still very important for you to write that formula. Substitute what we know. We know A is, so 100. We know B is 16. So together here we get 116. What's 2 times 10? 20 times 4 minus 80 cosine 25. degrees. And using this form of it, it's just simple. We just type it into the calculator and go for it. So C then is ultimately going to be the what of that quantity? The square root. Now, why am I not worried about the negative square root as I write it, though? It's the length of a triangle. It can't be negative. So let's go into the calculator. So we get the square root of 116 minus 80 cosine 25 degrees. Close off my angle. Close off the square root. 6.6. Yes? C equals 6.6. Questions on using the law of cosines to find a side? Okay. I want to take you to a Regents problem for an angle. I believe it's an algebra B, I think. It's going to be tough to find. All right. Farmer has a field. And he needs to fertilize the field. Obviously, if you fertilize your crops, you get a better harvest. Farmer needs to fertilize his field. His field's in the shape of a triangle. One of the sides is 75 yards by 83 yards by 102 yards, roughly. Fertilizer costs $6 a bag. One bag covers 25 square feet. So $6 per bag. Each bag covers 25 square feet. 25 square feet is a measure of what? Area. So ultimately, we need to find what here? We need to find the area of this figure, right? Okay, so I'm kind of jumping the gun a little bit. What's our area formula? How do we find area? Two sides times the sine of the included angle. So what's our issue here? We don't have that angle, do we? We know all three sides. We don't know an angle. Could we use Hero's formula? Yes. Or how are we going to find the angle? We've got to use law of cosines to find the angle, right? Does it matter which angle we find? We can find any one of the angles. If we know all three sides, then any angle that we find, we will know the two sides that surround it. My rule of thumb on these problems, I always found either the largest angle or the smallest angle. So let me go ahead and label this. We'll call this triangle A, B, C. So this is side B, side C, and side A. Which angle would be the smallest angle? B would be the smallest angle. So let's find this one. So tell me, please, what would the law of cosines look like to find angle B? Cosine B equals B squared. And now does it matter the order in which I subtract the other two? Absolutely not. Minus A squared minus C squared divided by negative 2 AC. Okay. So we're going to have 75 squared minus 83 squared minus 102 squared divided by negative 2 times 83 times 102. Now, if you're going to type this all in at once, what do you have to be very careful of? You have to be very careful of your parentheses. We need a parenthesis around the whole top, and we need a parenthesis around the whole bottom. Okay, so be very careful with parentheses. And now, again, this is going to tell me the cosine of angle B. Good luck today, ladies. Okay, so I'm not going to ask you for the full value, but when you get the value, what are you going to do to it to find the angle? Second cosine. So when you evaluate that, second cosine it, and I want to know the full angle. Why do I want to know the full angle? Now, ultimately, I'm being asked to find the what? Area. This is a step involved in finding the area. I will not round this value. I'm going to use the full value, and as a matter of fact, I'm going to take that value and store it as B in my calculator. What is the full angle? 0.35, 0.24. Okay, I need to use that full angle. I can't just whimsically round it wherever I want or truncate it wherever I want. I need to use that full angle, so I'm going to store it as B so I don't have to type it in anymore, though. Okay? So now I know angle B. Now can I find the area? Yes. Now I can come back and say, okay, my area is equal to 1/2. What are the two sides that surround angle B? Yeah, 102 and 83. So 102, 83, sine for area, and we want to use the angle B that we just plugged in. So half of 102 is what, 51? So I'm just going to type in 51 times 83 times sine B. And again, we need to find the area, but ultimately we need to know how many bags of fertilizer we need. So I'm not rounding the area either. I'm using the full value. What did you get for the area? $3,067 square yards. And I'm sorry, I've used foot up here. I've worked square yards. Each bag covers 25 square yards. Okay, so it's $6 per bag. Each bag covers 25 square feet. I need to know how many bags we're going to do here. So what do I need to do to figure out how many bags I need? Okay, divide that by 25 for me, please. We're going to have to. We're going to have to round it up. I mean, if we need... we may have a partial bag that we're not going to use, but we need more than we need less. If we have less, we're not going to be able to get it. So what do you get here? 120. So we need 123 bags. 122 is not going to cut it. We need 123 bags times $6 per bag. Farmer's going to need to spend... Yeah, take me up to the nearest $10. Round it up to the nearest $10. $740, roughly $740 for the farmer to fertilize his field. Okay, so he hopes that there's no floods, there's no freezing, or droughts, or that the deer don't come out and eat his. So using the law of cosines here to find an angle. Okay, any questions on using the law of cosines, folks? Okay, they're both extremely easy. Okay, they're both extremely easy, which is a little easier, though. Law of sines is slightly easier. It's just a proportion. You're solving a proportion. But what do you have to have for law of sines? A side angle pair. So if you ask the question, do I have the side angle pair? If the answer is yes, you use law of sines. If not, you've got to use law of cosines. Both can be used to find what or what? Sides or angles. Both can be used to find sides or angles. We'll get into the area formulas on Monday, folks. Again, tomorrow is just going to be a work day for the juniors that are here. And then we'll pick back up with the area formulas on Monday with Hero and just the basic trig formula for the area. And we're getting very close then to the end of the unit here, folks. Very close to the end of the unit.